Hi everyone, this is a video to help you with your data collected from the pH probe titration. To take that data, amalgamate it in order to create what we're calling a titration curve, which is a graph of those results. From that graph, which you'll need to include in the assignment, we can read off a volume of hydrochloric acid that got us to a pH 7 when we were titrating against the sodium hydroxide. So the information on this page I've tried to include as a recap. I'm not going to read through it all, but as a recap, this one is our kind of rough run where you can see that the volume of hydrochloric acid that I dropped into the titration is roughly 5 ml apart, 5 centimetre cubed apart, and pH was recorded at each of those volumes. In yellow here we've got the two volumes where somewhere in between there pH 7 was hit, but we kind of whizzed past it because this wasn't accurate. There's 5 ml between, or over 5 ml between these two values, and pH 7 would have occurred somewhere there. In our run 2 we started from around this safe volume here. And as a recap, you've all done this in the lab, but we titrated at smaller intervals. So here I'm going by about 1 ml, 1 centimetre cubed at a time. And again, I've highlighted here the two values or the two volumes where we were above 7 and then suddenly we were below 7. So we're zoning in on that end point a little bit closer here. So in the third run, I've gone to my safe volume indicated by this one here, which is about 24, and I've titrated at much closer intervals, and I've managed to more or less hit the pH 7 there. So you will have something like this. Yours might be a bit longer than mine. You might have lots more numbers than mine, but the principle is the same. I'm going to quickly show you how you put these numbers all together and produce your graph from it, which is needed for your assignment. So the first thing I would suggest doing is going down here and opening up a new sheet. What you're going to need to do is just grab all your numbers, and that was Control C to copy them, and I'm going to paste them Control V into there. I'm going to do that with all three tables, so Control C, I'm just going to drop them in like that. And the last one, Control C to copy it, and I'm just going to paste those in Control V. So what I've done there is I've just taken all of the numbers, and you will do this with yours, take all of the numbers into a new sheet. I'm also going to take, I'll do that afterwards actually. Once we've got these here, ideally what we want to do is sort them by volume. This is volume here, and this is pH. So I'm going to go over to this column and click on a number, and if I right click, I'm going to sort, and I'm going to choose to sort from smallest to largest. So from smallest volume all the way up to largest. So what it's done is just sorted them. So all of this big jumble of numbers is now in a sensible order from smallest to largest. You can do that with your data. What I would like to point out is that you will get some of this going on. So for example, I had two readings at 25.1 mil, and they were close but not exactly the same value. Don't worry about that, keep them in. It's all going to average out in the end, so we'll just keep that all there. What I will do is just take one of my headings here and put it in the top, and if I double click here, it will just mean that I can read my headings, and I'm just going to remove the colour coding now because I don't really need it. So that's really what we need to do. We need to take those raw results and we need to get them into a table and sort them from smallest volume to largest, and not worry too much where we have duplication and slightly different values. So once we've got our data in this form, what I would like you to do is highlight the whole lot. Please notice that I'm going to do that again, but I haven't highlighted the headings. Sometimes this causes problems in Excel. If I highlight from volume across to pH and down, that can get a bit messy sometimes depending on what graph I choose. So I'm actually only highlighting the numbers. And I'm going to go to Insert. And I'm going to choose, for now, yeah, I would say choose the scatter graph. Sorry, I'll just hover over it. Scatter with smooth lines and markers. We'll go for that. Okay, so what we're going to get is, what I hope you get is this very characteristic shape where you have a sort of gentle decline and then a sharp decline, almost vertical, and then it goes to a more gentle slope at the end there. So what you'll need to do with this is give it a nice title, something like and then put your chemicals in there. We were doing hydrochloric acid as the known against sodium hydroxide as the unknown, but some kind of title for this graph. When you've done that, you will need to click on the graph whenever you want to add something and go to this plus chart elements, and we're going to want axis titles. So we need to know of our x and y axes which is pH and which is volume. Always sense check this by just looking at the numbers. So here our top value is something like 27, excuse me. So if we look at our numbers, 27 here is to do with volume. So we know that the x-axis is going to be volume. Make sure you include the unit, and you're just going to edit these by clicking into them. And then we know obviously that this one will be pH, which is correct because the value, maximum value for pH is around 13, which is what we see here. Just to think about interpreting this graph, what this is saying is, if we think of the beginning of the x-axis here is the beginning of the titration, and as we move along we're adding more and more volume of our hydrochloric acid, in reaction, this is what the pH is doing as we titrate. When we whiz past the end point, as we often did with our results, we didn't get 7, we went from something like 9 down to something like 2 or 3. This is why. It's because this acid-base reaction is quite slow and gentle to start with, but it kind of snowballs near the end point, and we get a very sudden drop down to pH 7. And before you know it, you've shot right past pH 7 down to here. So a nicely labelled graph with a title. Something else you might want to do is add your minor grid lines. They've put the major ones in there. The minor ones might just give you a bit more detail. When you've done that, you'll need this graph in your assignment. You'll need this table in your assignment. And you'll need your original tables in your assignment, and you'll need an interpretation of this graph to find the volume of hydrochloric acid that was needed to titrate and reach the end point of pH 7. So however close you got as a volume for pH 7, so for example in my data I got one very, very close to 7, even if you didn't get that close to 7, the benefit of this graph is not only can you kind of see in more detail what is going on with the reaction and the pH, but even if you didn't get a value on 7, you can locate pH 7 on this axis, read across, and even if I didn't have a data point there, I could see that wherever I intersect this line, I can read a value off the volume axis down here. So for my assignment, I'd be reporting that a volume of 25 centimetres cubed was required. I can then use that volume in my calculations to find concentration of my sodium hydroxide. Okay, so I hope that's helpful, guys. That's taken you through raw data to how to get it into an amalgamated table and then how to produce this graph. Good luck.